So we have our run function that we use right here. And now we could nicely use here also, because we first want to create our assignment and then also do some auxiliary action. And the ultimate thing that we want to do is change assigned to true, where we could now nicely use apply. And then we end up with this abomination. Hello everyone and welcome to the first episode of Idiomatic Kotlin. In this series of videos, I'm going to showcase useful Kotlin features that will help you to write Kotlin code in an idiomatic fashion such that it follows the best practices of this beautiful programming language. For each episode, examples in a public Git repository are available to optionally see how each idiom would be applied in the real world. But I will also cover all of that in the videos themselves. In this first episode, we're going to take a look at scope functions. I will walk you through why they exist, which they are, and what their typical use cases look like. For each scope function, I'm going to give an example for your understanding as well. So let's get right into it. Let's kick it off with the why. The general idea of scope functions is to condense your source code. Essentially, it is nothing else but some syntactical sugar. All the things you can do with scope functions are equally possible without them. They will just make your code more concise and in many cases also more readable and maintainable. The second common reason is to bundle together source code that you do not want to be separated at any point in the future. This means that code blocks that perform a connected task are visually clustered together and will also be harder to accidentally separate when refactoring. We'll see an example of this in a minute. Finally, using scope functions, you can limit the scope of the pieces of your code, as the name already implies. It is of course an excellent practice to scope variables in the smallest possible way to minimize mutability and make your code less error-prone in general. Now, let's get to the meat of this and walk through each of the functions that the Kotlin standard library offers. In the list on the left, you can see all 5 scope functions that exist. I specifically ordered them in the following fashion. We will start with the least complex and easiest to use ones, getting more advanced later on. Furthermore, I also ordered the list when it comes to the usefulness of each of those functions, in my personal opinion of course. I will give you examples of how I use them generally and which I use more often or fairly rarely. As I mentioned in the beginning, I prepared real-world-esque examples for each of the functions. Thus, if you want to follow along, you can find the examples of this episode in a public repository on GitHub, which is linked in the description under the video. Both a branch as well as a tag exist for this episode as well as the following ones. Alright, let's begin with the first one, which, as I mentioned already, is the easiest to use and also the one you're going to use the most often in day-to-day programming, at least in my personal opinion. The scope function itself is an extension function that can be invoked on absolutely any object. The argument that you receive in the expression is a reference to the object the scope function was invoked on, so the piece in front of the dot. I put the argument as id here to show that you receive it as a single argument. We will see counterexample of this on the following slides. To understand what this scope function is doing, we just have to look at the return value. Regardless of which code you put in the lambda expression, the scope function will always return the object that it was invoked on. In other words, the id argument. Now with this knowledge in mind and the name of the function at hand, you might already have guessed what it's used for. The idea is to easily chain the execution of some arbitrary code after the preceding code finished executing. What does this precisely mean? Let's check out an example. As I mentioned already in the beginning, for each of the scope functions and also for all the following videos in this series, I prepared some real-world-esque examples. So the idea here is this is not some code that I'm actually running somewhere, but it looks like and it is written in a way that it could be code that you would encounter in the wild. The idea being, of course, that this is a lot easier, in my opinion, to actually understand how you would use the scope functions in all the other idioms we're going to look at, compared to having a 2-line like arbitrary example that you would never write like this in day-to-day programming. So let's get into it. What we have here is a repository, so some database access for developers, so some collection or table of developers. We can quickly look at the developer data class. It is just very easy. We have a name, a type, an email address, and assigned. This we need later. And then what we have one method here that finds us all developers that are of a certain type. So it literally just does where the type is equal to the given argument. And we can quickly have a look at the type. For now, there's just a front end and back end, and it's an enum. So these are the only options for our developers for now. Yeah, that's that. So this is just, we give a type, receive every developer in the imaginary database that has this type. Now where it gets interesting and where we move to the example is this other method here, find random developer by type. As you can imagine by the name, we also give it a type, but we only receive a single developer or none. So it's a nullable type. And what we do is we just query for all the developers in the database that have the given type. And then we just, with this built-in collections extension function of Kotlin, we get a random one or null. The null one being, of course, if the set would be empty. So if there's simply no developer of the given type here, let's say we give front-end, but we only have back-end developers in database, the set would be empty. Therefore, this one would, in the end, be a null value. So that's that. And then, of course, we want to return this. And now comes a piece of code that you've probably seen 100 times before, at least I have, and maybe not in the exact same way, but I'm pretty sure you've seen this before. So what we want to do here essentially is we want to return this, right? You see this is also the return argument. But before that, we want to do some auxiliary action. In this example here is something that I oftentimes see in production code is that we want to log something. So we have already our result and we want to return it. But of course, there's in many functions and programming languages, same with Kotlin. After returning something, we cannot do any other actions. So we couldn't log something here anymore, of course. Therefore, this is our only real option. We have to save our return value into a variable, do our auxiliary action, and then return. This is not very idiomatic Kotlin, since, the whole setup is a bit ugly. We're only like a slave to the fact that we cannot return after this, but it's if we could, we probably would, since the method arguably would be easier to read if we just say get all the developers, select a random one, return it. And also, by the way, I want to log. And now you might also already see where this scope function comes handy. So let's replace all of this code with the alternative. So what we're doing now is we're still getting our developers and we're also still selecting a random one or null, but we immediately return this. And now you see where the scope function and also its name comes in handy. So we return a random or null developers out of the set, and also, that's where they ultimately got the name from, we do this other action that is kind of like required of some sort because apparently we want to log here, but it's not really part of the business logic. So if we would get rid of this, the code would ultimately function the same way. And there's many other examples like this where we need to do something, and logging is a good example of this, before returning. So as you can see, this code is exactly the same as beforehand. We just log. And now what you see here is that our it argument is whatever we invoke this on. So in this case, the nullable developer. I could, of course, also do this here. And then it has a name. So this is just our argument. And the rest is the same. We check if it's null. Not null. In this case, we log, okay, we found someone. Or if we didn't find anyone, we say no developer with type X could be randomly selected. So this is one classic use case of the also extension function. Of course, there's many other ways you can use this. In general, it is useful to chain an action behind some other action that is auxiliary of sorts. I would not recommend to use it for something that is just like a real side effect of your code. So if in here you call some other thing, some other class, or some service, let's say, you can do that. In some cases, that might make sense if it's something that is like, that's not 100% part of your flow of this method. Then, though, in general, I would probably put it just as a new line. But this is a perfect example of it where this is something that you want to happen, but it's not really it's not really part of finding a developer, right? It's something that's nice to have, but it's not really required. So this is perfect here. And now it also reads a bit more like an English sentence. We can say we select all the developers, we get a random one, and also, by the way, please do this logging action here. Of course, this works with any other setup. So if you have anything where you need to, after you did an action, do something that is like auxiliary to it, then this is the extension function for you, a scope function rather. Of course, what we can also do here now is even inline this, such that we have it even more concise. Not sure if you like it, but that would of course be possible. Let's move on to the next one. Just as also, this scope function is an extension function as well. Instead of receiving a separate argument, the scope within the lambda function is bound to this, referring to the object that the function was invoked on. It also always returns that object. As you can see, this scope function has the same properties as the first one we saw, with the difference of the lambda argument. What exactly the this refers to, we'll see in just a moment. The use case you'll also see quickly then, which usually is to use setters on the object more idiomatically within the Kotlin language. That's all still very abstract, so let's check out the example, shall we? Even more than with the previous one, I'm certain that you've seen this before. So what we have right here is a service that notifies our developers that we saw a second ago. And we do this in this case, or at least in this first method here, via email. So what we do is we notify a random developer of some incident, let's say. We have a notification here, and we want to pick a random one out of the type that you saw already in the previous example, and we want to send them this notification via email. Let's just quickly look at the notification. It has a type, which is not super important right now, as well as the text itself, so to say. So what we do, of course, is we select a random developer again with actually the method you saw just a second ago, where we now are using the also scope function. And what we want to do in this case as well is, in case that we could not find any developer, we want to throw an exception here with this built-in Kotlin error method, such that if we have a null value here, which is what this else operator is used for, we throw this exception, which automatically removes the question mark here, since now we can be certain that this variable will be non-nullable. And what we do next is use the JavaX mail library. So that's also part of the Java standard library to send emails. So what we do is we create a MIME message, with the session of email that we received here. This is all part of this library. And we create this email. And now, of course, we have to set up the email. So this is the part I was referring to. I'm sure not in this exact form, of course, but of course, this is something you've seen 100 times. This thing does not have a constructor where you can pass in the arguments, but instead you just construct it with a session, and then you manually have to set whatever you want on the email. The reason in this case partially is because it allows for, I think, like almost 50 options. So the constructor would be outrageously large. And secondly, many have the exact same type. So switching around two arguments in the constructor, since Java does not have named arguments, would be a very easy mistake to make. So that might be a reason why they opted for this one. So what you have to do now, or what we do in this case here, we set the recipients. It's not super interesting what exactly happens here. We take the developer's email address, of course. We set the reply to, which is our own address. This is just down here, a static constant. We set when we send this, which is just right now. The subject, which is not implemented yet, but we can generate it out of the developer and the type of notification. So this would be like alarm or something. And finally, the text, which is similarly not yet implemented. And then finally, we invoke send, which is actually also a static function out of this Java library, and give it the email, and it's sent. If, of course, behind this, the transport of the mail server setup. As I said, this is just an example, of course, but this code in theory would work just fine. Yes. Now let's focus our attention on this part. It's arguably pretty ugly. At least I personally really don't like it. Partially, it is also ugly due to the fact that we have to mix here between like traditional setters that we have to call and give it something, and setters that we can use with the property access here. So usually, of course, you would say set reply to and pass in this. But in this case, IntelliJ will tell us use of setter method instead of property syntax, which is a bit more idiomatic already. But ultimately, of course, these are all just setters. So we would set this, set that, set this, set that, and maybe another 50 things. And then finally, we send our email. This is not very pretty. So what we can do instead is use a scope function. So let's just replace this whole chunk here with this. Not a whole lot has changed, but we'll see in a second some pretty interesting improvements. So what you see here right now is that we have our email message, but it is like constructed in one go, so to say. So what we do is we still give the email session to the my message, but now we call apply on this, and as the this argument, we receive again whatever this was called on. So far it's very similar to also, but what we do here is we apply, and that's why it's called apply, this lambda argument with the context of the object we invoked it on, which is bound to this. What it means in this case to be bound to this is just that here you don't have to say it.set recipients, it.reply to something. This would actually be the case if this would read also, which would work just as fine. You see now the rest is red and doesn't work anymore. But in this case, you can use also just fine, since here we just receive our message as the it argument. So we can just say the message, we set the recipients and the reply to, and so on. Ultimately, we still don't want to return anything, since it automatically will return for us whatever we invoked it on. But this ultimately also looks a bit ugly. So instead, the only difference between also and apply is that instead the context of the whole lambda is bound to the object we invoke on, such that if we just have the method in the middle of nowhere here in the lambda, the Kotlin figures out itself that this is referring to that's the same as this essentially. Or of course, if we would have used also with this way. So you can just dump the method directly in here, and it automatically is clear that it is called on the object. So now you might argue, yeah, okay, I see now it's like it looks a bit different. It's essentially the only difference for you from the outside may be that it's all indented by one layer here. Apart from that, of course, this still stays exactly as it is, which is just a restriction of Java, really. So we cannot really change that right now. So the reason, by the way, being here that this doesn't work is that this accepts way more things. So this is not really a setter. As you can see, this accepts 2 arguments. So Kotlin cannot figure out what to do with the regular setter syntax here, because this is, of course, meant for actual traditional Java setters where you have some field and you just override it. And this is technically speaking not a setter, it's just also start with set. That's why we have to use the regular invocation right here. So from the outside, we might have not gained a lot, but what we did gain is actually quite a bit. So the first thing that is now way nicer is that our instantiation things, or well, the code that we use here for instantiating the message is nicely scoped away in this block. So what I mean by this here is that this is the reason I gave in the beginning, that now it is a lot more difficult to accidentally refactor it and get rid of some part here or something. And also, if you copy this around, it's a lot easier to take this whole chunk instead of starting to copy and then you forget the last line, for example. This is secondly to that, this is a very nice visual aid here, that here we start constructing our object and here it ends. So I would personally at least argue this is visually helping a lot, that I see, okay, this is indented one layer. I have the closing brace here. So this is just to construct my email message. This, of course, also can be collapsed nicely. So you see here at the side, this whole thing we could collapse. So we don't even see exactly what we have. We just see we have the message and we apply some stuff to it, and then we have our variable. That's another thing. And in my opinion, the biggest upside of this here is that we can Of course, not really, but we can get something that is a bit closer to immutability. Of course, this is like really the counterexample of immutability, since we can, it would be nicer if you just construct it once and then the message is immutable. Instead, of course, we can, as we do right here, we mutate it with every of these calls, and then we finally send the mutated version. No one stops us from here saying accidentally, of course, email dot subject is now test, right? I mean, this is an easy mistake to make. I mean, in this case, it would be very obvious, but you get the idea to slip this in here somewhere. Maybe that's like, if this happens, blah, 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 and then accidentally in some condition, you do this. Maybe, well, let's say like if my environment is test, then I change this to test, and then accidentally you don't change the environment, and boom, we have that. So this ultimately, arguably, would be better if our email would be immutable, because then this couldn't happen. Then you at the beginning you have to say, if I'm in test, then I construct it with the test subject. If not, then I take the production one. But the whole thing here doesn't allow for that. The whole object class, rather. But what we do gain here is like something that is a bit, at least borderline immutability. What I mean by that is that we have now a single chunk here where we instantiate our object. Of course, this can still happen that I showed just here, that you override it later. But what cannot happen so easily anymore is that you accidentally drop a piece here. So if we go back to the previous code, it is quite easy to make the mistake that give me a second. It's quite easy to make the mistake that, I don't know, you comment this out, or you accidentally remove it outright, because ultimately this code is a bit hard and ugly to read. You have your email here, then you do a bunch of other things, and if it would look like this, which of course many people do, I mean, I just added the new lines here to have it visually a bit more separated and more obvious what's going on. Arguably, I would say it's a very easy mistake to make. You want to remove something and you accidentally remove too much. You don't have a unit test maybe, or you don't test this part, and your code has a bug. With the other way of using apply, we do not have this issue, because this is like nicely scoped away now. So my point being that once we have the variable here, we can be certain that, of course, we can still mess up the code, but at least in this scope now, we can be certain that it has all the fields set that we intended to set on it. So we cannot arrive at a point where we have like a half constructed email and then send it. Because another thing that you could imagine, for instance, is, let's say we have this again, and this time around we have a bug where we accidentally do this. Right? That is something that actually can happen quite easily. Let's say we have here some conditionals again, and in some case we might want to send it already. So in the middle here we send it, and only then we set the text. Of course, we wouldn't have this part then. So the email again is sent incompletely. Thus, if you go with the apply function right here, this cannot really happen, since the variable at least will always be complete in the sense of whatever you do in the scope of the apply scope function right here. This next function is an interesting one, as it differs from the signature of the first two. It first takes any object as an argument, and then a lambda as the second. The scope of the lambda is the same as with apply, so this, as you saw in the previous example. The same goes for the return value. What is the difference then? Most often, this scope function is leveraged to execute multiple steps on the passed-in object with the block scope of the lambda. Let's study the example. Otherwise, this one is one of the more confusing ones. Let's jump into the next example. This one is a lot less complex, so all that we want to do here is format a greeting line for a given developer. You can imagine that this would, for instance, be used in the context of the previous example to format the first line of our email message. All that we do right here is format the greeting, which just says dear developer, and then we take the given names, so multiple first names that a person might have, and join them together with spaces, add another space, and say their last name, their family name, and a comma. So arguably a bit stupid code for an entire class, but bear with me. The other thing that we then want to do is we want to see if our greeting matches this regex right here, which just means that it only contains letter, like word characters, so no special characters, or spaces, and arbitrary many of those. So, and finally, of course, here the comma. So we would just verify that there's no special characters in our greeting. If it does not match the regex, we throw an exception saying that it does not conform to the rules. Otherwise, we return the greeting. Now, what we can do here now in this first line is that we want to construct a string in this case that always has the developer as its scope, you could argue. So what you could do to replace this whole thing here is this. We instead immediately return and we say with the developer. So this is, as you can see, the first argument. And then within this lambda here, we again have the argument this time here in the parentheses bound to this. So what we can just do now is, without any other return here, because it's the only thing in our lambda, we just immediately start our string, which is exactly the same as beforehand. But as you can see now here, all the arguments within this lambda are bound to the developer. So instead of saying developer.name, we can just say name, given names, name, family name, and it's automatically clear that this refers to this, the developer. So we can have the code here a bit shorter and a bit more concise. This is a bit of a tiny example, let's say, because the other one was not horrible either. But if you would use the developer object here, let's say 50 times, maybe you needed to format a very long string, it would be very annoying at some point to always prepend developer dot, which also blows up your line limit very quickly, and you just write the same word 100 times. So this is ultimately what the with scope function is necessary, or not necessary, but useful for, because you can just say within this lambda function, everything that I write is, so to say, prefixed with developer dot, which ultimately means, of course, that you can leave it out everywhere and make your code a bit shorter. The other thing we do right here is I also start combining the functions, so you could see how this could be used. So what we also do is on the string, once we have constructed it, we of course wanted to do our regex check to see if it conforms to the rules. So just on the string, because it's just an object, of course, we invoke the also function and then just see if it doesn't match, we throw an error. Otherwise, we do nothing. And ultimately, of course, as you know, this returns whatever it was invoked on. So in our case, the string, which we finally return from the entire method. The next scope function is curious for the reason that it's the first one on our list that is not an extension function, while also not receiving any argument within its lambda. Instead, the function can just be invoked statically as any other static Kotlin function. Let's say like println. The idea of this function is to construct an object whose construction steps are scoped within the braces of the lambda function. For that, whatever you return from within the lambda function is also what the entire run function itself returns. Let's check out the example to make this one really clear to everyone. This is the first scope function where we're not going to have a before and after. Instead, I'm going to directly start with the after, so to say. We're moving from notifications right here to assignments. You can think in this case as an assignment within this imaginary code base as something like a ticket. So what we want to do is assign these assignments to our developers. Each assignment has a name or a unique identifier, which is not just a numeric value, but something that also contains letters and can have different types. So what we can have here, which we should look at first, is the assignment type. This is just an enum, which for now has these values. So we can either have a feature, a scheduled maintenance, an extraordinary maintenance, upgrade, or bug fix. And as you can see, each of those have a sign, so to say, so like a shorthand that uniquely identifies them. So these are the letters given here. What we want to do right now is create a regex, so just as with the greeting line in the previous example, that can verify that any assignment name that we generate conforms to whatever rules we want to have, which is, part of this regex. You can check this regex yourself under this URL right here. So to see how this will work if you don't have a lot of experience with regexes or cannot fully follow yet what this would do. This URL you can find, of course, via the Git repository, and then just copy paste into your browser to play around with the regex and see what values it lets it pass and not. So what we want to have is that our regex starts with the prefix ASS for assignment, then follows a hyphen, then any of the type signs. We're going to look in a second what that means. And finally, we want to allow any number of digits. So just multiple digits behind each other of arbitrary lengths in total. That's our regex. That's the rules that our assignment names have to conform to. So what you can see here right now is that this line is really the interesting one, where we construct the regex. We save this in our companion object here into a static static value to then later use it, which we're going to see in a second, to verify our assignment names. So what we do right here is we have the prefix defined here as this string. Our type signs are constructed in a way that we take all the assignment types that there are, all the enum values, and join them together with a pipe. For those of you who don't know, in regex, this is just defined as like an OR operator. So what this would mean here is that because we chain together all of the signs, so the F, MS, and so on that you saw here in the assignment types, we chain them together with the pipe. What this would mean, if you put it here into the regex, is that it tells the regex expression validator allow any of the values that are separated by the pipes. So in this case, this would mean any of these are allowed as the next value after the first hyphen here, but nothing else. You cannot put any other string here. Then follows another hyphen, and then our digits, which is just this part, also a regex. And now you might already have seen or guessed what, in this case, the run function that is just statically invoked here in the middle of nowhere is useful for, because we have a nice scope for our regex construction. So instead of saying, of course, we could like inline all of this, right? This would work very easily. That we do this would have the exact same meaning, of course. Now we also don't need the run anymore. We can just put it right here. But I'm not sure about you, but honestly, this is pretty like hard to read, you know? Have fun deciphering what someone meant. And I mean, this is still a quite easy regex. If you would have something that is more complex and has way longer rules, let's say you want to validate an email, which is notoriously difficult, email address that is, this regex would be unreadable. So if someone tells you, oh, your assignment today is to debug this because something is not right with this regex, this would be very annoying. Instead, what we want is that these separate parts have like a bit more descriptive names, as you saw here. And this is, of course, what I did here. So here it's very clear to everyone that reads this code at any point later on that they see, this is the prefix. Okay, these are the type signs that are allowed. And these are finally just an alias for digits in regex. And the nice thing right here is, and this is where the run function comes in, all of this is scoped, hence the name scope function, within this lambda function, such that you don't have to do something which would be arguably quite ugly, that you here say val prefix is something, and then you clutter your companion object with things that honestly the companion object either firstly doesn't need to know about and also should not need to know about, because this is only something that you need in the context of constructing your regex, but not anywhere else in your class right here. And this is precisely summarize the use case of run and actually many of the other scope functions, because now you cannot access prefix right here. I cannot here say chain prefix to it. It will say like, this doesn't exist, because of course it's scoped within this lambda right here. The other nice thing that you gain from this is that, of course, you can edit it way easier, apart from the maintainability aspect. I already mentioned that each part has a nice descriptive variable name. So if later on someone decides that this should now just start with A, it's as simple as that, and now the prefix is just A. That's ultimately the idea of the run function like this. To construct something, in this case the regex, with some extra information. Of course, if you just construct it directly, passing in your arguments, you don't need this. But if you need some auxiliary variables, that's really the idea, to construct this, or at least to make it a bit easier readable. And this is a very nice way to do it. Generally, as a tip, you can always also take this part here and put it into a separate static function. This would also always work, of course, and this is how you would usually do these kind of things if you really want to in Java. So we could do of this, of course, and say build regex, and then, of course, not use a run function anymore. That doesn't make a lot of sense. This is something you would see otherwise very often. But now, arguably, this is worse, or not only arguably, I would definitely say this is worse, because this has a single use case. It's only used here, of course, and this is also never going to change. This is like not reusable at all. There's not going to be any case ever that we're going to want to reuse it, also because it doesn't even take any arguments, because if we really want to reuse it, we would just use the variable. And even if it's outside, we could just make it public. So this function is kind of useless. It just sits here to help us make this read a bit easier, but it just adds visual clutter and a function that could be inlined. Of course, you cannot inline it in Java. And as you saw, funnily enough, if I do inline it in Kotlin, it automatically does it as a run function. So you can even see this is like the recommended way by IntelliJ and therefore the Kotlin developers themselves.
Wait a minute!
We had run already, right? Yes and no. To clear this one up, there's two flavors of this scope function. It works exactly the same as the other one, with the difference that it is used on an already constructed object. The common use case of this version of run is that it can be nicely chained using the save call operator, the question mark with a dot, to modify a non-null value, and only in the case that it is not null. Let's look at the example. All right, we're back in the same class where we saw our previous example. You might have already wondered why I was scrolled down all the way to the companion object when there was clearly some code here on top of this. This is, of course, for the other flavor of run. What we have in this example is an assignment service. Don't worry about the one here. You'll see in a second why. That we can create notifications for maintenance with. At the same time, though, assigning an assignment to our developers, which is why we need this regex down here. And save in the database that we assigned a developer with the assignment, and also return the notification here that we could then, as you saw previously, use to send them an email after calling this. So with the return value of this, we could pass it into our email and our email function and send the email. So what we do right here is we, again, as you saw already previously, find the random developer. And once again, if there's none found, we throw an exception such that we have just a non-nullable developer right here. What you want to do then is mutate the developer object and say that now it is already assigned to something. The reason for this, of course, here being that, again, at the end, we want to return our entire assignment. So we cannot really we could construct the assignment first, then say we assigned them, then persist the developer object where now the assigned value is flipped to true, and then finally return our assignment. In this case, it's not really necessary since we don't even use any information out of the assignment. We just say it's assigned. Of course, this is just like a toy example. This wouldn't make a lot of sense. You would probably have a reference what they're assigned to. But let's say in our example, this is all we need. We just need to filter later on which developers have an assignment at the moment and which do not. So we set their assigned to true, and then we save them back into the database. As you can see here, this is our developer repository. Function is not there yet, but as you could imagine, it would just update the object in our database where now the value is true instead of whatever it previously was. And finally, we want to return a new assignment with a name that we generate right here. This is where you could now imagine that the regex is being used. It's not yet, but this would make a lot of sense that we generate the name, and then once it's generated, say, is it complying to the rules specified by this regex? We also say who are the developers that are assigned to this, the type of the assignment, which we received here, and finally some like default message that the assignment has. Then we, on the assignment, call a method that generates a notification. It also doesn't do anything yet, but it would return our notification such that we can continue using it later. And now this is an example where we could use the other flavor of the run function. So if we would take this whole chunk here and replace it with this, and this of course looks like that, we again immediately return something and instead just do some other auxiliary actions, so to say. So what we do in this case here is we also get our random developer, and now comes in the part where the run can be helpful, because now we say with the save call operator only in the case that our developer is non-null. So what this would mean is that if it's non-null, we go into the lambda, and if it's not, we skip this entire lambda right here and instead go here, where now here we say if it's non-null, which it is if we ever reach this point, then or rather not if we reach this point, because we would also reach it, of course, if the function finished running. But if it reaches the point because it's null, we again throw an exception, just as the previous one. So what we can do now nicely is that just easily chain based on if the previous argument is null or not, do something on the value that we call it on, in this case, our randomly chosen developer. So what we do right here is, since it's bound to this, we can just say assigned is now true, because the whole lambda refers to the developer. And we also save it, giving it actually this here as the developer argument, because, yeah, that's the developer. And the rest here is exactly the same as we saw previously. Now you might also be able to tell why I mentioned in the beginning of the video that I ordered the list in the beginning based on usefulness, because in my personal opinion, this is not a huge improvement to the previous one. The previous one was very similar. Ultimately, the only thing that we have here that's a bit easier to read maybe is that we only execute this if our developer is not there. But there you can, of course, argue that that's even nicer to first draw a developer, then check, do we have the developer? If not, immediately abort the whole thing. So you not even try to start doing the assignment. Of course, this would also not happen in this case because we skipped the entire block. But let's say you have some other actions later on. I could see why people would argue that this is actually a downgrade. Hence why this is so low on the list. I personally use this pretty rarely since it has quite limited use cases. Right. Let's look now finally as an example in this sheet here with how you could combine multiple extension functions together. You already saw it briefly in a previous example, but let's make it a bit more extreme right now. And as a warning here, this is probably not what you want to do. But we now have here our run function. And let's say that in this case, we cannot just simply say where's the developer is assigned right now and only then create the assignment. But we first want to have the assignment and then do something with that assignment on the developer object. So we have our run function that we use right here. And now we could nicely use here also, because we first want to create our assignment and then also do some auxiliary action. In this case, we want to, of course, use developer repository and save this, the developer. And the ultimate thing that we want to do is change assigned to true, where we could now nicely use apply. To say assigned is now true. And then we end up with this abomination. As you can see, you can bring it too far. I cannot recommend doing this because this code is not super readable anymore, since there's a lot of side effects happening that make it a bit hard to read. I know what you're thinking, and you're right. Technically, there are indeed 6 scope functions within Kotlin, but I only counted run once. I guess you can see why. But now let's talk about let. In my personal opinion, the let function is a bit useless, as it barely differs from the letterren function that we looked at, which already is quite useless. Literally, the only difference is that instead of it receives this. Man, what a sentence. Let's quickly check out the difference in the use case, which is also very minuscule. Now we're back with assignment service 2. Now you also know why there was a number 1 and number 2, since this is literally the same example as the previous one, but the only difference that if we use the let scope function, our argument here, in this case the developer, is not scoped to this, such that we can use stuff like this here, where we can just call something on the scope of the function, whatever we invoked it on, but instead we receive an argument such that, in this case, the it by default, of course, which is still our developer. We could, of course, introduce a more telling name. This would, of course, have the exact same effect, and now we use this. But yeah, and you can see this is the only difference literally between let and run, the type of argument. You could argue, of course, that the relationship between run and let is pretty much the same than between also and apply, which is that it just differs what exactly you receive here. That is true. The main reason why I would argue that let and run are a bit less useful is that their use case themselves is not very large. As you saw in the previous example already, what we did here with run and now do with let is arguably done better without them. There's sometimes I do use them and I find a nice use case for them. However, these ones, and that's the reason why they're at the very end of the list, are the ones that I use very rarely, almost never. On the other hand, apply and also have clear use cases in my mind, which, as you saw, for also was chaining some auxiliary action behind a previously finished action, and for apply to use setters within Kotlin more idiomatically. The same goes for the run without being an extension function, which was, in my opinion, very nicely usable for the construction of the assignment regex that we saw just a minute ago. So in my personal opinion, these three, also, apply, and run as a static function, are the most useful scope functions. That's it. You've seen all the scope functions that Kotlin has to offer. I hope you got something out of this video, specifically when it comes to the examples that I prepared for you. Let's check out the final words. I would recommend to you to check out those examples again if anything wasn't entirely clear yet. You can, of course, also leave a comment below. I'm happy to help. As I mentioned in the beginning, you can find the examples in a Git repository linked in the description under this video. Secondly, I can only recommend that you do not overuse them. As you saw earlier, the code doesn't really increase in conciseness anymore at a certain point. Something to also always keep in mind when trying to make your code more idiomatic is that it usually also gets harder to read for people that are not as advanced in the language as you are. This goes for every programming language, by the way. Therefore, I only use them if I value the increase in brevity enough over the increase in complexity. Oftentimes, I would argue that nicely used scope functions can even decrease the complexity, as they make it really clear what the scope and thus the reasoning for certain lines of code are. However, it is very easy, as you saw earlier, to just use them at any point where you can use them, which makes your code very unreadable and ultimately more complex at some point. And finally, I can of course only recommend that you try them out for yourself. If you are not yet as versed in Kotlin as you would wish, I will also have more video courses on the language itself. Trying them out, however, will also help you with point number 2, as you will quickly develop a feeling for when to use a scope function and when it's better to stick to the conservative way. Let me know in the comments which scope function is your favorite and if you have any additional use cases for some of them that I did not cover today. Apart from that, if you enjoyed this video, make sure to leave a like under it, consider subscribing to the channel for many more videos like this one, and share it with other people that might be interested. Finally, all that's left to say for me is, see you next time when we look at more idiomatic Kotlin. Tschüss!